Now, acceleration is related to the velocity of an object. There are three possibilities that can happen with an object when it gets an acceleration. First, the magnitude of its velocity or its speed changes. This is the example of how the object gets the acceleration, so the speed changes. And the second one, the direction of its motion changes. So this is the example, and we will discuss this later in the circular motion. And the third one, well, you can say that both magnitude and direction of the velocity changes. So when these are changed, you can say that this object is accelerated. I will show you how to write and understand the meaning of acceleration. So acceleration can be written like this or like this. They are the same. However, the second one could probably help us to get better understanding of its meaning. So, if an object is being accelerated 10 meters per second, means that every second the speed of an object is increasing 10 meters per second. So remember this very important definition. 10 meters per second means that every second the speed of an object is increasing 10 meters per second. Interestingly, I noticed that in one of the lectures given by Professor Lewin, he also explained the meaning of acceleration, so he wrote in the unit meter per second per second. Here I show you the actual example. If a car, if it's accelerated 10 km per hour per second, let me write 10 km per hour per second, meaning that every second its speed is increasing 10 km per hour. So, if a car has a zero speed here, so the initial speed is 0 km per hour or it's at rest, and then in 1 second it will gain 10 km per hour, and the speed now becomes 10 km per hour. And then now after 2 seconds, the car will gain another 10 km per hour. So now we add the speed, so it becomes 20 km per hour, and so on. At t is equal to 3, the speed become 30 km per hour, and then 40 km per hour. So as you can see here that the increasing value of the speed is the same, which is 10. But now, if the car has non-zero initial speed, for example, if the initial speed here is 5 km per hour and then it's accelerated 10 km per hour per second, and after 1 second it will gain 10 km per hour and its speed becomes 15 km per hour, and then its speed become 25 km per hour, and then next become 35 km per hour and 45 km per hour. So keep in mind that in the motion with constant acceleration, the speed will increase with the same amount of value. In other words, if you decelerate an object, then this object, the speed of this object will decrease also in the same amount value every second. Let us now get some practices, but I want to tell you for the acceleration that I will write the acceleration like this, 2 meter per second square instead of 2 meter per second. Alright, now suppose we have an object that has an initial speed 5 meter per second and then it's accelerated 2 meter per second square. Now we are asked to find the speed after it moves 7 seconds. So how do we solve this one? First, let us now see again the meaning of 2 meter per second square. So the meaning is that every second the speed will increase 2 meter per second. So if the object moves 7 seconds, now the increasing of speed here becomes 14 meter per second. So using the simple proportionality, you can get this. So this is the increase of speed, or I'll call this delta V. So this the first important thing that we need to find. Now, if this object will have an increase of speed 14 meter per second after 7 seconds, and then his initial speed is 5, then the final speed will be the initial one plus the increase of the speed 14. So his final speed will be 19 meter per second. Now, if there is an object that has an initial speed 20 meter per second and then it's accelerated 5 meter per second square, so what's the speed of this object after 8 seconds? Again, the meaning of 5 meter per second square here is every second the speed will increase 5 meter per second. So after 8 seconds, you can find that the speed will increase 40 meter per second. So this is the increase of the speed, or delta V. Now, the initial speed is 20 and then the increasing speed is 40. So the final speed here, V, is the initial speed 20 plus 40. So you'll get 60 meter per second. And at the end, if you have an object that has an initial speed v0 and it's accelerated with a, you can find the value of the final speed here after it moves for t seconds. Here again, a here is that in 1 second the speed will increase a, and after t seconds then the speed will increase a times t. So this is the increasing speed, or delta V. And if this object has the initial speed v0, then the final speed will be v0 plus delta V, or a times t. So at the end, you'll find the relation between the final speed, initial speed, and the acceleration and time. But you don't have to memorize this, and I do not recommend you to do that. Now let us see another type of the problem. So suppose you have an object that has an initial speed 60 meter per second, and then after it moves for seconds, the speed becomes 100 meter per second. So let us now find the acceleration. Alright, first what we need to think about is the increase of the speed, or delta V. So here is just the final speed 100 minus 60, so you'll get 40 meter per second. Or we can say in 4 seconds the speed increased 40 meter per second. So now what's the increasing speed in 1 second? And here you can find that the value is 10 meter per second. So 10 here is the value of our acceleration. So it's 10 meter per second square. And let me rewrite again how we get this value. So that's from 100 minus 60, that's 40, divide by 4. Now let's see if we have an object that has a initial speed 20 meter per second, and after 5 seconds the speed becomes 50 meter per second. So let's find the acceleration. Alright, now first, what is the increasing speed, or delta V here? And we can calculate that's 50 minus 20, or 30 meter per second. Now we can write like this. In 5 seconds the speed is increasing 30 meter per second. So now let's find the value of the increasing speed in 1 second, and you can find it's 6 meter per second. So here 6 is our acceleration, 6 meter per second square, or the meaning is that every second the speed is increasing 6 meter per second. And let me rewrite again this, how we get this. So that's from 50 minus 20 divide by the time here, 5 seconds, so we'll get 6. Or in general, if you have an object that has an initial speed v0, and after t second this speed becomes v, and we are now to find the acceleration. First you need to think about the increasing speed, or delta v. It's v minus v0 as we solve in the previous problems, and the acceleration here is just v minus v0 divided by t. Of course, this is not the formula you need to memorize, and again, I also do not recommend you to do that, but you can always get this acceleration when you get more practice and practice, so you will understand the relation of the acceleration, final speed, initial speed, and time. And of course, if we calculate that a times t is equal to v minus v0, we should get the initial relation that v is v0 plus a times t.